Hey there! In this lesson, we're going to review atoms and isotopes, and then build on that knowledge and start talking about ions as well. So, quick review. We know atoms are made of three particles. They're called protons, neutrons, and electrons. And which one of these three particles identifies what the element is? That is correct. It is the proton. You can have different forms of this same element where the number of protons is always constant, but the number of neutrons can vary. And we call this an isotope. So we know carbon always has 6 protons. If it doesn't have 6 protons, it is no longer carbon. But it can have anywhere from 6 to 8 neutrons and between 2 and 10 electrons. So if it does not have 6 neutrons, we call it an isotope of carbon, and that particular atom is heavier than our standard or our most abundant carbon atom. So that isotope is the form of an element that has a different number of neutrons than the normal or the average. And we know carbon has 3 such isotopes. We have carbon 12, carbon 13, and carbon 14. Carbon 12 has 6 protons and 6 neutrons. Carbon 13 obviously has 6 and 7 neutrons, and carbon 14 has 8 neutrons. And remember in our previous presentation I told you that carbon 14 is what we use to do some radioactive dating of previously living things. Notice that the number of protons, however, did not change. Most atoms have naturally occurring isotopes, including radon, potassium, uranium. And this also ties into what we know as radioactive elements. This means that it has an unstable number of neutrons. So it's an unstable isotope. And then our last topic today is ions, which is something new for us. This is where we're going to focus much of our time. An ion is an atom that usually has a neutral charge, so meaning it has the same number of protons and electrons. Remember that protons are positive, electrons are negative. When that atom becomes an ion, it means that it has lost or gained at least one electron, and it's become charged either positively or negatively. So if you lose negatives, you become more positive. If you gain negatives, you become more negative. So let's take a look at how this happens. These are really good visuals. Pay attention to the visuals that this video gives you because it will really help in understanding how to determine whether the charge becomes positive or negative.
Here's a diagram of an atom. It's not perfectly accurate, but for what we need right now, it's going to do just fine. So in this lesson, we're going to look at characteristics that we can use to describe atoms like this one. You know, if somebody asked you to describe a person, chances are you'd use characteristics like the color of their hair, the color of their eyes, what their height is, and so forth. Just like that, there are characteristics we can use to describe atoms. The first of these characteristics, and maybe the most important, is the atomic number. The atomic number is often abbreviated by a capital letter Z. And what the atomic number is it's the number of protons in the nucleus of an atom. In my diagram here, I'm using these red circles to represent protons. So I have 1, 2, 3 protons in this atom. So the atomic number is going to be 3 for this atom here. Atomic number is particularly important because the number of protons in an atom tell us what kind of an atom it is. And by that I mean, is it a carbon atom? Is it an oxygen atom? Is it a sodium atom? We're going to talk more about that in the video on isotopes, so you don't have to worry about it for right now. The next important characteristic that we can use when describing atoms is the mass number, often abbreviated by uppercase A here. Mass number is the number of protons plus the number of neutrons in the nucleus of an atom. People always get confused by mass number. Here's why. Atomic number is the number of protons. So everybody always wants mass number to be the number of neutrons. But it's not. It's the number of protons and neutrons. In fact, there's not really a name for the number of neutrons, just the number of neutrons in an atom. We just don't use it that often. So anyway, for mass number, we want to count all of these together. 1, 2, 3, 4, 5, 6, 7. The mass number of our atom here is going to be 7.
So just based on this information, if you were to go to a periodic table, either in the back of your book or the dynamic periodic table online, you could tell me which element this guy is talking about. If we look at the number of protons, and that's the only piece of information you really need, we could see that 3 protons, and so we'd look at the third spot on the periodic table with the big number 3, that's lithium.
Now finally, the third characteristic we're going to talk about here is probably the most complex, and that's called net charge. I don't have a good way to define net charge. I don't have a good definition. So what I'm going to say here is it's how protons and electrons balance each other out. Let's talk a little bit more about this. So net charge is about how protons and electrons balance each other out. So protons, as you know, have a positive charge, and electrons have a negative charge. So that means that if we have the same number of protons and electrons in an atom, like I have right here, 3 protons and 3 electrons, I'm not drawing the neutrons here because we're not worried about them. Here we have the same number of protons and electrons. They're going to balance each other out. This 3 minus is going to balance out the 3 positive, so we're going to end up with an atom that has a net charge of 0, because these two things balance out, and we can call this atom neutral, which means that it has no net charge. Now, what would happen in an atom where we have 4 protons and 3 electrons? We don't have the same number of electrons and protons anymore, so they can't.
So just based on the diagram that he's given you here, is this atom, well actually is this ion, going to be a positive ion or a negative ion? Well, you can tell here you have more positives, so it's going to be a positive ion.
Can't totally balance each other out. Instead, we have more protons than electrons, so that we're going to have a net charge that's positive, because there's going to be some of this positive charge in the protons that can't be balanced out by the electrons. In this case, we have 1 more proton than electron. So this is going to give us a net charge of +1. Since our atom has a net charge, we give it a special name. We call it an ion. An ion is any atom that has a net charge. Neutral is what you call it if you don't have a charge. Ion is what you call it if you have any charge. Okay, this is where we have 1 more proton than electron. What about this case here? What if we have 5 protons and 3 electrons? In this case, the charges don't balance out either. But now I have...
We do have names, specific names, for when the ion is positive and negative. We'll get into that shortly. But if you look again at the diagram, not balanced, so not a neutral atom, which means we call it an ion. And in this case, it's going to be a positive ion. You can tell how many, you can tell what the charge is. It would either be plus something or minus something. You can tell what the charge is by looking at the difference between number of protons and number of neutrons. This has 2 more protons, so it's going to be a charge of +2.
I have 2 more protons than electrons. I've got 2 more protons that aren't getting balanced out by these electrons. So that means that I'm going to have a net charge of 2+ for these 2 protons. And again, this is going to be an ion because it's got a charge. Now the opposite can happen as well. Here is an example where an atom has 4 electrons and 3 protons. So now it's got more electrons than protons. These 3 protons can only balance out 3 of the electrons. So I have 1 more electron that's not getting balanced out. That means that this total charge is going to be -1. That's a charge of this 1 more electron that I have in the proton. And if I had a case in which I had 5 electrons, oh, and I should have said, we call this an ion, because it has a charge, just like this. Negative charge, positive charge, it doesn't matter. If it's got a charge, we call it an ion. Okay, so anyway, we have a case where we have 5 electrons and 3 protons. Now there are 2 more electrons and protons. So I have 2 negative charges that aren't getting balanced out by the proton, which means that I have a net charge of -2, and this also is an ion. So that's how you can figure out net charge. So what's the net charge for this atom? Well, we have 1, 2, 3, 4 electrons, and we have 1, 2, 3 protons. Since they're different numbers, the protons and electrons aren't going to be balancing each other out. We have 1 more electron than proton.
So what you need to think here, if you want to figure out the actual charge, which is a number, you need to figure out, do we have more negatives or do we have more positives? In this case, we have more negatives. So our charge is going to be a negative charge. And then you just assign the difference between the numbers as the charge. So in this case, our charge is -1.
So that means that we have a net negative charge. And since there is 1 more electron than proton, this atom here is going to have a net charge of -1. So now that we've talked about these 3 characteristics you can use to describe an atom, let's look at the practice problem video so that you can go over this in a little bit more depth and try a bunch of examples.
And that's basically what we're going to do. I do want to spend a little bit of time talking about very briefly, just going over the names for positive and negative ions. So when an atom loses electrons, so basically think it's losing negatives, it becomes more positive. If you're getting rid of those negative particles, but your number of positive particles stays the same, then you become more positive. In other words, you're subtracting negative numbers. So for example, the charge, if we look at the charge of this particular neutral atom of gold, gold is Au. If you're looking at your periodic table, which you should be doing, if gold lost 4 of its 79 electrons, it now has 79 protons and 75 electrons. If we think about this, it has more positives than negatives. So it's a positive ion, and it's going to have a charge. If you just look at the difference in the numbers, we've got a difference of 4, so it's going to have a charge of +4. The neutral form of magnesium lost 2 of its 12 electrons, so it now has 12 protons and 10 electrons. Again, the positives are greater than the negatives, and the difference is 2, so this is a positive ion of +2. We also have negative ions. If an atom is gaining electrons, meaning it's gaining negatives, it becomes more negative. Since electrons have their negative charge, the more you have, the more negative you become. And we represent these ions by placing a superscript. Superscripts, think like Superman. Yeah, superscripts are going to be written above the normal line of writing. So superscripts are the numbers like you see like exponents. They would go up. You write this superscript charge number next to the atomic symbol. For example, here we know, oh, we've got a -2 up here. That means oxygen is an ion. And it's got a -2 charge, so would it have more electrons or more protons? If it's negative, we're going to have more electrons. If we see K+, that means we have 1 extra something. We've got a positive charge here, and since there's no number, we can assume it's 1. So this is potassium with a +1 charge. It's got more protons than electrons. N-3, or N-3, is nitrogen, and this has more electrons than protons, so it has a -3 charge, and so on. So the elements we see on the periodic table are neutral atoms, and their mass is an average of all their isotopes. Remember, atomic mass is the average of all those isotopes. But when we round it for calculating the number of neutrons, we always get the most abundant isotope. So let's look at some examples. Identify the following as either ions or isotopes of each other. On the left, we have carbon. Protons are the same number. Neutrons are a different number. And electrons are the same number. If protons and electrons are balancing out, that means it is a neutral atom, so not an ion. And if the neutrons are not the same, this makes it an isotope, one being slightly heavier than the other. Next element is nitrogen. 7 protons. In this case, on the left we have 8 electrons, and on the right we have 7 electrons. So, on the left, our nitrogen atom is slightly more negative. It has a -1 charge, which makes this an ion. If the neutrons are the same on both left and right sides, then it's just an ion, not both an ion and an isotope, which can exist. Pb is the symbol for lead. Pb has 82 protons. You'll see on the left we have 82 electrons, so this is a neutral atom so far. On the right we have 83 electrons. Okay, that makes it slightly more negative, so on the right side we have a negative ion by a -1 charge, and our number of neutrons is also different. So lead in this case is both an ion and an isotope. And finally, lithium. 3 protons on the left, 2 protons on the right. Don't be fooled. This is a trick question. If this is 3 protons and this is 2 protons, this is not lithium. 2 protons would be helium. How many protons, neutrons, and electrons do we have for each of the following? And then label them as isotope, ion, or the version found on the periodic table. So here we have copper. Copper 29. This is telling us it has 29 protons. If the atomic mass is 69, we can figure out 69 minus 29 is 30, so it has 30 neutrons. If we look at calcium, we can see this is calcium plus 2, so this is an ion, that's right. It's telling us that we have 2 more positives, so 2 more protons than electrons, which tells me if my protons are 20 and we have 2 extra protons, then my electrons will be 18. And to figure out number of neutrons, we're doing 43 minus 20, which gives us 23 neutrons. So we have an ion of calcium. Ag is silver. We have an ion of silver with +3, so we have more positives than negatives, which means if our protons are 47, that means we have 3 extra protons. So 47 minus 3 gives us 44 electrons. And if we're figuring out number of neutrons, we need to do 108 minus 47 to get a number of neutrons of 61. And finally here we have oxygen, -2. Anytime you see a charge next to the symbol, we're going to know it's an ion. Oxygen, in this case, has 2 extra negatives, so 2 extra electrons. If our protons are 8 and we have 2 more electrons than that, so our number of electrons would be 10. And our number of neutrons would be 18 minus 8, which gives us 10. What I did not do was go to the periodic table and look up the atomic mass, or the mass number. So your job is to figure out whether these are isotopes or not. All right, any questions, please make sure you let me know. Have a good day.